Welcome back. This is an Aleks training video on predicting relative forward and reverse rates of reaction in a dynamic equilibrium. So you've got some stuff. You've got some acetic acid, some ethanol alcohol, and it forms some ethyl acetate and water. And you've got a forward reaction going from reactants to products. You also have a backwards reaction going from products to reactants. Eventually, it's going to reach an equilibrium where the rate is going to be equal on both sides. Forward and backwards are equal. So that's what equilibrium means. The rates of forward production is equal to the rates of backward production. That's what equilibrium is. It's equal rates. So you're going to now do some perturbation, I think they call it. You're going to disturb the system somehow by removing some of the ethyl acetate. So you're going to be removing some of this guy. Okay, so it's one of the products. So if you remove a product, Le Chatelier says it's like a hole, and the other side will move towards it, temporarily going faster. See, right, this is going the same rate as this, but if I make a hole, this will temporarily speed up and go and shift towards the right to fill that hole. That's what it means. And then eventually it reaches equilibrium again, and once it reaches equilibrium again, the rate of forward and the rate of backwards is exactly the same again. All right, I think from that you should be able to answer all four of these questions. Here's the first. What is the rate of the reverse reaction before any of that ethyl acetate's been removed? Okay, so the rate of the reverse. If you remember, it's at equilibrium. Equilibrium means that the rate of the forward and the rate of the backwards is the same. Okay, so they're going to ask you, can't be zero because they're both moving, they're both making something. Greater than zero but less than the rate of the forward reaction. No, that's not at equilibrium. Greater than zero and equal to the rate of the forward reaction. Yes, that's what equilibrium means. It's greater than zero and equal to the rate of the forward reaction. Okay. Now, what is the rate? Here's the second question. What's the rate of the reverse reaction just after it's been removed? So now I have a hole, and so this is now going to shift to the right, a temporary shift to correct that perturbation, and then eventually it'll reestablish equilibrium. So as it's moving to the right, what's happening? Well, they're all greater than zero because they're both working, they're both doing something, they're not going to be zero, and so this is the reverse. So what's happening here right after? Well, it is greater than zero, but which one's going faster now? In order to make up, it's shifting to the right. That means the left side is moving faster temporarily than the right side. So the forward reaction is moving faster, the reverse reaction is moving slower temporarily. That's what shifting to the right means, temporarily in order to reestablish equilibrium. Well, in that case, it's greater than zero, but less than the rate of forward reaction. Okay, because it's coming at it. It's coming from reactants to products. So it has to be going slower than what's coming at it. Third question, what is the rate of the reverse reaction when the system has again reached equilibrium? Well, if it's reached equilibrium, equilibrium means the rates are the same. So it's going to be the same as before, greater than zero and equal to the rate of the forward reaction. Anytime it's at equilibrium, that's what that means. Last question. How much less of the ethyl acetate is in the flask when the system has again reached equilibrium? Okay. So they added some stuff. It was already at equilibrium. They added 57 millimoles of the ethyl acetate and then let it reestablish equilibrium. All right, so what happens? Remember, we took away some. We took away some of this. It moved forwards. So is it going to fill in the entire 57? Well, No, it's not going to fill in. It's not going to fill in the whole 57. It's not going to have the same numbers as before because we actually took stuff out. It's going to have a new balance. Okay, so it would be like if I shared my lunch with 10 people and then I took 3 people out, I'm still sharing my whole lunch, but I'm sharing them with less. It would be adjusted. The amount would be adjusted. So if I took some of that stuff out, then we're having forward reaction. You're not going to fill in the entire 57. You would fill in less than the 57. Okay, so there would be some less, but it's not going to be 57 less because I took some out, and so this is moving out to fill at least some of that 57. So that's where we have here. I think that may be the harder of the 4 questions. This idea of how much less. Well, it's not it's not all gone, and it's not completely refilled because it's readjusted. Okay, so it's just a thinking problem. It looks scary because there's lots of words here, but the questions are not as hard as you might think.